Hello, this is Jake Sherwood, and this is Lab 3, Magnetic Field of a Bar Magnet. For the introduction, we have first the purpose. The objective of this experiment is to measure the distance dependence of a magnetic field due to a bar magnet and compare to the distance predicted by the equation. Some of the fundamental principles we'll be using are magnetic fields, the Biot-Savart law, linearization formula, dependence distance formula, and for the main results, we have n equals negative 2.75 and the mu equals 1.868. Some of the assumptions we made during this lab is that the phone is aligned north and the bar magnet is aligned with the magnetometer. The bar magnet is also represented as a dipole, and the system equals the bar magnet. Surroundings are everything else. Some of the steps of this experiment are download the magnetometer app and find the location of the chip in your phone. And then we needed to line up the phone so it's oriented north. Therefore, the magnetic field is also zero. Measure the distance between the chip and bar magnet, and we're measuring on axis and perpendicular, as you can see in the diagram below. Some of the observations we made after the lab is that as the magnet started to become further apart from the magnetometer and the distance between them increased, the magnetic field approached zero. When the distance between the magnet and the magnetometer became closer, the magnetic field increased. As you can see with the data and calculations, you can kind of see a linear relationship between the natural log of the magnetic field and the distance, which showed as distance got closer, then the magnetic field increases, as I explained before. For the glow script code, we just use this to calculate the magnetic field at different points. And for the output, you can see here's the output of the code. So for what if you hadn't oriented your experiment to compensate for magnetic north, had instead laid out your meter stick at home at some intermediate angle with respect to Earth's magnetic field? How would your results change? So the results would not be accurate because if you hadn't compensate for the magnetic north, Earth magnetic field would interfere with the bar magnets. What if you were to stick two identical magnets together end to end and run this experiment again? How do you expect your measurements to differ? So the direction of the magnetic field would remain the same. However, the magnitude of the magnetic field would increase. Some of the errors that were experienced during this lab potentially were that the phone may have not been properly aligned with the magnetic north, which would have Earth's magnetic field interfering with the experiment. You could also, the location of the chip wasn't properly accounted for inside the phone. And also there was potential human error in calculating the distances. So for the conclusions, magnetic dipole moment calculated by the code was fairly similar to the one from the magnetometer in the phone. As the distance from the magnetometer to the bar increased, the magnetic field approaches zero. And also on the other side, when the distance decreased, the magnetic field increased, which has been explained. And the findings were consistent with theoretical physics on magnetic fields. So because the equations that we used in the lab and the glow script code aligned pretty well. And that's the lab.